Hi, we're going to talk about what logarithms are and how to evaluate them. First of all, let's discuss the notation. This is what logs look like. This number here, the one that's going to be written slightly below, is what we call the base. There are restrictions for the bases. Base has to be a positive number, and it also cannot equal 1. Other than that, it can be anything that you want. So how does it work with logarithms? Let's take a look at an equation in exponential form. 2 to the third power equals 8. You can rewrite that equation in a logarithmic form, and this is what it's going to look like. If you look very carefully where all the numbers went, you should see that the base of the exponential expression, which is 2, right here, that number is going to end up being the base of the logarithm. And so this you read that as the log base 2 of 8 equals 3. So let's take a look at the next problem and see if we can figure it out. So we have log base 2 32. And essentially the question we have here is 2 to what power equals 32? And if you think about this, do a little bit of simple math in your head, you should be able to figure it out that the answer is going to be 5. So the answer here is 5. How do we check this? If you take 2, raise it to the 5th power, you will get 32. All the numbers here match here, and that's what we have. Okay. So what we're going to do is we're going to take a look at some problems now that are going to ask you to evaluate logarithms. The one thing that you need to understand about these particular problems is that they are meant to be done without a calculator. So could you in theory use a calculator here? Yes, but these are meant to be simple enough with this concept that I just explained, so you should be able to do it. So log base 3 of 81. 3 to what power equals 81? 3 times 3 is 9, times 3 is 27, times 3 is 81. We have a total of 4. The answer here is going to be 4. You can always check that by writing the following statement and checking that to make sure it's okay and correct. So here, log base 5, 125. What number, 5 to what power is going to give you 125? That's going to be 3, because 5 to the third is 125. A little bit of decimals here. 0.2 to what power is going to give you 0.04? If you do 0.2 times 0.2, this is 0.04. That means we are dealing with power 2. Now, something with reciprocal expressions. So we got 1 over 64, and the base of the log is 4. So we're trying to figure out 4 to what power is going to give you 1 over 64. Since we see a reciprocal expression there, that probably indicates that we are going to have a negative exponent. If we forget about the reciprocal, 4 to the third power is 64. If you do 4 to the negative third power, it's going to be 1 over 64. That means the answer here is negative 3. In case if you have any questions, you can refer to properties of exponents that explain to you how to handle negative exponents. But really quick, just to remind you, if you set it up like this, this is equivalent to 1 over 4 to the third power, which is 1 over 64, and that's exactly what we have here. This seems a little scary maybe at first, but it's actually not that bad, because you're doing 1/2 to some power that's going to end up giving you 1 over 128. So 1/2, if you look at that and not 1/2 just as 2, then 2 square is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128. We have 1/2 and 1 over 128. The answer here is going to be, what did we say? 7, right? This last problem here is very similar to what we had right there, except now the base is the reciprocal of 3, and here we have 27. So we know 3 to the third power is 27. That means 1/3 to the third power is 1 over 27. But we want to get the reciprocal because we want to get 27, not 1 over 27. That means we are going to have -3 as our exponent here. Alright, now we're going to take a look at some problems that require a little bit more thinking, because these are meant to be fairly straightforward. Here's what's going to happen here with the other problems. And I have to warn you about some of the common mistakes here. Sometimes students look at this and say, oh, I know 4 times 2 is 8, so the answer is 2. Well, 4 times 2 is 8, except we're not trying to multiply, we're trying to raise a number to the power. So we need to think about 4 and 8. What do they have in common? They share base 2. 4 is 2 squared, 8 is 2 cubed. So what's going to happen then, if you rewrite it this way, this is basically going to tell you that your exponent is actually going to be 3 halves. 3 on top, 2 on the bottom. We're talking about this 3 and this 2. So you can think about the next problem in a similar fashion. 9 and 27, again, be careful. If you multiply 9 by 3, you are going to get 27, but the answer here is not going to be 3. We're looking for a power. So we're going to look at that. 9 squared is, 3 squared is 9, and 3 cubed is 27. So this is log 3 squared of 3 cubed, and the answer here is also 3 halves. Again, same exact idea, 3 and 2. Log base 64 of 32. Again, we need to find a common base for both numbers. So what we have here is 32 is going to be 2 to the 5th. They both have 2 as a common base. 64 is 2 to the 6th. So if you write it like this, log base 64, so 2 to the 6th power of 2 to the 5th power, our answer is going to be 5 over 6, 5/6. Okay, and the last problem here, again, you should probably recognize that we have a reciprocal base. So when we're going to set this up, we are going to treat 1/8 as something that has base 2. So I'm going to take a look at 1/8, and I'm going to remember that since it's a reciprocal, it's going to be 2 to the power -3. 32 is 2 to the power 5. And now we're just going to rewrite all that. So we're going to have log base 2 to the -3rd power of 2 to the 5th power, and our answer is going to be -5 over 3. And that's pretty much the basics of evaluating logarithms. I hope this helps.